Forest regeneration is an important aspect of regrowing forest or renewing tree cover by establishing young trees naturally or artificially, generally after previous stand or forest has been removed. The method, species, and density are chosen to meet the goal of the landowner. Forest regeneration includes practices such as change in tree plant density through human assisted natural regeneration, enrichment planning, reduced grazing of forested savannas, and change in tree provinces and genetics of tree species. Human assisted natural regeneration means establishment of forage age class from a natural seeding or sprouting after harvesting through selection, cutting, shelter, harvest, soil preparation, or restricting the size of a clear-cut stand to secure natural regeneration from surrounding trees. Enrichment planting means increasing the planting density, that is, the number of plants per hectare in an already growing forest land. These activities influence carbon storage through changes in the growth of above ground and below ground tree biomass and changes wood end use. The impacts on the litter layer and soil vary with many factors. Generally, over the rotation period, annual growth in carbon storage in tree biomass in most cases is much higher than soil or litter carbon storage. Regarding carbon sequestration, the connection between forest regeneration and the end use of wood is extremely important. High densities can lead to rapid crown closure and early growth, but such stands reach maximum increment early and may suffer onset of mortality and rapid growth decline, thereby potentially becoming sources of carbon considerably faster than stands that are managed at lower densities. Additionally, trees that are grown in less dense conditions generally reach suitable size for solid wood products earlier. As a result, harvest and conversion to long-lived wood products occur sooner, adding to the stock of sequestered carbon and substituting for non-wood products that may use more fossil fuel in their production. All these activities are used today with varying intensities in many countries, both developing, underdeveloped, and developed, without consideration of carbon sequestration, largely on the basis of decisions about present cost and expected future benefits from timber and other forest values. If carbon management is introduced, these activities could be effective in sequestering considerably more carbon than it's occurring today. At least two methods are commonly used to quantify changes in carbon stocks from this practice: existing forest growth yield tables and forest inventories that measure standing and increment of above ground stem volume. The second method can be done as accurately as one wants through with increasing cost. The biomass growth processes are well known. Soil carbon accumulation is generally less certain. Mortality caused by wind, fire, pest rot, or insect damages can lead to loss of carbon pools for all these activities. Most yield tables include estimates of natural plus mortality rates. Regarding accidental mortality, fewer estimates exist around the world. The accuracy of national forest inventories varies considerably from one country to another. This level of accuracy is based on different permanent sample plots, of which 20% are measured each year, varying from one country to another. Sometimes some countries provide very reliable measures of their forest resources and stand growth, while others provide a very average values and cannot be considered to be serious data. The accumulation time for above ground and below ground biomass ranges from 5 years to 150 years or more on low potential sites in boreal forest. The tree biomass carbon accumulation process is not difficult to quantify and predict, particularly where well-developed forest growth and yield models exist. So hence it is important to understand that forest regeneration is not only the act of regrowing or renewing tree cover by establishing young trees naturally or artificially, generally promptly after the previous stand or forest has been removed, but it also includes a very important aspect of recreation and protection of our ecosystem. Natural regeneration is the process by which juvenile plants and copays that have established naturally replenish plants which have died or have been killed. Over time, following a disturbance, the growth of natural regeneration will re-establish tree canopies. At the passive end, there is spontaneous regeneration, where trees and other native vegetables regrow and naturally on the land. But it is important to actively grow them, and actively not only planting of trees are important, it is also important to pay attention that the growth of tree or the regeneration of the stands are taking place at a recoverable rate, without which there will be not much significant help with respect to the forest regeneration. Regeneration is very important in the sense that unless it is taken care of and maintained scientifically over a period, it causes regeneration unsuccess, in which stands may grow or they break down without proper replacement. Hence, it is very important that these things are taken into consideration when replanting or remodification or revegetation is considered. The tree species considered has to be estimated, the plant densities, the distance between the plants, whether there will be random planting or very selective planting needs to be decided, the type of the forest, the ecosystem, the local weather regimes, available precipitation, the forest fire history, and the kind of species that thrive easily in that particular forest is very important. It is also very important to always select trees or vegetation that are relevant to that particular ecosystem. Introducing exotic species of trees that may be high timber yielding or fast growing may not be a very good suggestion or an idea, because it changes the ecosystem of the existing forest, which is not a good thing to do, as it is detrimental to the long-term interest of the ecological system operating in that particular region, and also for the conservation of the local biodiversity. Hence, native trees must be given priority. Nurseries should be created that specializes on the regeneration of growing the seedlings of native tree species by the collection of seeds from the forest, or through nursery work, or through plant tissue culture propagation, in which micropropagation of plants is done in that laboratory condition, and then these plants are regenerated by taking them into the forest after they have gone through their growth in the nursery. Hence, it's a very delicate and important issue, and particularly with climate change and global happening around the world, and carbon sequestration becoming an important issue globally, regeneration of forest is a very... Shoykot Kumar Basu, Bureau Report, Kalinga Chronicle TV.